Good morning, everybody. I hope you guys are doing well, and we are going to continue our discussion on what is a mole, and we celebrated Happy Mole Day, and hopefully you have that little song still buzzing around in your head. And we're going to define this now. We're going to take a look at what is really a mole. So you can see here it's a unit of measurement, and we discussed in class if I say a dozen, you know that it's going to be 12. Well, if I say a pair, it's going to be 2. If I say a mole, it's going to be 6.02 times 10 to the 23rd. So no, we're not talking about this hairy creature over here that I have here on the right. We are talking about a defining unit of measurement, 6.02 times 10 to the 23rd. So we talked about in the last few chapters, probably chapter 3 now, we talked about AMUs. And if you take a look at silver on the periodic chart, you can see that it has 107.9 atomic mass units. Then its mass means that it is going to be 107.9. Well, this is their mass for every mole of atom that they have. So if you take a look at copper, and I look at copper on the periodic chart, did I already grab a pen? Maybe not. If I take a look at copper on the periodic chart, it has a mass number of 63.5. So we would say that's 63.5 AMUs, or it would be 63.5 grams per 1 mole. And so that would be grams per mole. You should also write this here, grams per mole right here. So if we take a look, well, if that's that many grams in 1 mole of substance, how many atoms do I have? 6.02 times 10 to the 23rd. So just like we talked about, if I have a dozen textbooks versus a dozen eggs, they are going to weigh a different amount here. That's why we see masses that are different. But if I have a dozen of each, I have 12. If I have a mole of each of these, I have 6.02 times 10 to the 23rd. Now keep this in mind that this can be used, like I just said, a dozen textbooks, a dozen pencils, a dozen eggs. It doesn't matter. A mole can be the same thing. We often use it for things that are very small. Particles like atoms, ions, or molecules. Remember, if I have an atom of aluminum, it looks like this. If I have an ion of aluminum, it's Al plus 3. And if I have a molecule of it, it has to be combined with something else, like maybe aluminum oxide, and that would be the formula for aluminum oxide. I can use the mole for any of these substances because they are all incredibly small. Okay, so if we take a look at why this number, well, it's the number of atoms that would have a mass equal to the atomic weight, which is on the periodic table, expressed in grams. So as we just did in the chart, if I have sodium, I look it up on my chart. You may not have this many significant figures, but you get the idea that that is that many grams in 1 mole of a substance. So now we should be able to do some conversions here. So we have our first one. It says how many atoms are there in 25.3 moles of carbon? So you're going to see me do mole maps, and I've given you a mole map in class, and you can follow along that if I am going from moles into atoms. They gave us moles, and the question is atoms, so I'm just going to convert from moles to atoms. So always start with what you're given. So I am given 25.3 moles. And I know that there is 6.02 times 10 to the 23rd atoms in 1 mole. So when I take a look at this, how did I know to put atoms on top? Well, I knew I wanted to cancel out these moles. So if I grab a different pen color here, you can see that the moles are going to cancel out. That's on top. This is on bottom, so I'm left with atoms. So I'm essentially just taking 25.3, multiplying by Avogadro's number, and again, 3 sig figs. So I need my answer in 3 sig figs, 1.52 times 10 to the 25th atoms. And this would be atoms of carbon. Okay, so that's all we need to do is we just need to multiply by Avogadro's number. So we have another example here that when we don't have something as simple as this, it says how many moles of fluorine atoms are there in 13 molecules of fluorine gas. So fluorine is diatomic. So I am going to start with molecules. So if you follow your mole map, we're going to change from molecules to atoms. And then we are going to finally end up at moles. Okay, so let's do this. So I have 13 molecules, so I'm starting here in my map. So I have 13 molecules of my fluorine. And you can see I'm writing a lot here. It really helps if we write down units and so that we know where we're going, we don't get lost in the process. So if I take a look at F2, look at that subscript, I have 2 atoms of fluorine. So I'm going to put 2 atoms of fluorine, and I know that there's 2 atoms in fluorine in every molecule that I have, and every formula that I have is a molecule. So I'm right here, I went from molecules to atoms, now I want to go from atoms to moles. So I look at my mole map and see what happens when I go from atoms to moles, and it is going to tell me that I need to divide by Avogadro's number. So I know that 1 mole is 6.02 times 10 to the 23rd atoms. So if I pay attention here to my units, I can see that molecules cancel out. Oh, sorry about that. Atoms of fluorine cancel out, and I am left with moles. So whatever you are ending up with should always be on the top of the fraction bar. It should be the last thing that you write. So I'm going to grab my calculator. I'm going to take 13 times 2, put in parentheses, divided by 6.02 times 10 to the 23rd. You should be trying this with your calculator as we are talking. And you should get 4.32 times 10 to the 23rd moles. Okay, so that's how many moles of fluorine, you can label that fluorine, that are in that molecule of fluorine gas. Okay, so you have a practice problem here. I'm assigning this to you. This should be on this page right here, page 184, and it's the one in the yellow box. So see what you can do with that and bring that to class tomorrow. Okay, we're going to touch on one more little topic here, and the next one is on molar mass. We're going to do a ton of molar mass. It's going to be second nature to you, and I think you'll find that it's pretty easy. So, refers to the mass of a mole of any element or compound. Mass of a mole of any element or compound. So we're going to use the atomic mass rounded to the 10th place. Sorry, I'm running out of my bamboo here. 10th place. And then we're going to multiply the mass by the number of elements and add values. So you're going to hear me talk a lot about do your atom inventory, do your atom inventory. So let's do that. So if I take a look at sodium hydroxide, you can see that these formulas are coming back now. That's why we had to do some review of that. So I have 1 sodium, I have 1 oxygen, and I have 1 hydrogen. Okay, so I'm going to look on my periodic chart and I'm going to round them to the 10th place. So when I look on the periodic chart, I have 1 sodium. Hold on 1 second here. Okay, sorry for that little interruption. You're probably going to hear the bell ring here shortly too. So we'll finish up. So if we take a look at sodium, you can go to your periodic chart and see that sodium rounded to the 10th place would be 23.0, and we've learned all about these sig figs and how important this is. Oxygen is 15.9994. That would round to 16.0. And then you can see your hydrogen, if you're looking at it, it's 1.00794, and that's going to round to 1.0. Add this all up, and I get 40.0 grams per mole. That's it. That's molar mass. That's how simple it is. So I'm just going to do the same thing. There's the bell. Time for lunch. We're going to finish up here quickly. So I have 2 hydrogens. Do your atom inventory. 2 hydrogen, 1 oxygen. Do the molar mass, round it to the 10ths again. So I have 2 hydrogen, and I look on my periodic chart. Hydrogen is 1.0. Oxygen, I have 1 oxygen times 16.0, its molar mass, and then I'm simply adding them up. I forgot to write that here. You're going to add them up. So I'm going to take 2 plus 16, and I'm going to get that the molar mass of water is 18.0 grams per mole. Okay, molar mass is not any harder than that. So what I want you to do is you guys should be able to do letter C by yourself. I want you to see if you can get 84.0 grams per mole. So that's the answer for this one. All right, and then the last one that we have here is you can read this first part that it's sodium phosphate, and this is dodecahydrate. That's what 12 means. And what this means is that 12 waters are added in. Well, if we take a look at ourselves, if we're carrying a heavy backpack and we put it on the scale, is that scale also part of the mass that you're seeing? Absolutely. So this water has to be added in to our compound. So we're going to do the same thing. We're going to do 3 sodium. We're going to do 1 phosphorus. We are going to do 4 oxygen. And then the easiest way to do this is just to keep water as a compound. We are going to use it a lot, and it's something that's why I had water in my last example here, that you can see that water's molar mass, let me see if I move that down, water's molar mass was 18. Well, you're going to use that number a lot, and so it's something that you'll just remember. So if we take a look, we have 3 sodium. So we're going to do its molar mass again, and you're going to start to memorize some of these that we use a lot. So we have 3 sodium, molar mass of sodium is 23.0. Phosphorus, we have 1 phosphorus, and its mass is 31.0. Here's our oxygen again, that's one you're going to memorize before too long. 4 times 16.0. And then we have our 12 waters, and we're just going to put in the mass of water, which we know is 18. And we simply are going to add all this up, do it in the calculator, make sure you verify my calculations. And I got 380, but it's not just 80, it's to the 10th place, 380.0 grams per mole. All right, that's it. That should help you out with the homework that we're going to be working on in class. So please make sure that you come with these notes completed, and you guys have a wonderful night.